Okay, we're here in part 2 of designing a gearbox. In part 1, we aligned these two gears according to a calculated center distance. So, I think we have lots of options here. Let's begin by just dropping a box on the work plane. And I'm going to set the height to 7 millimeters, just based on looking at my ruler and what I think, roughly the size of this thing should be. So maybe I want to grab these two gears using the shift option and pick them up off the work plane some set distance. It looks like I moved them up 35 millimeters, so if I move them up 7 we'll be exactly on here. Why don't we just go with 10 millimeters off the work plane. Okay, something didn't happen there exactly as I thought that it might, so I'm just going to move these up and out of the way now. Now I'll move my box in here, think of it as a plate, and we're going to start laying out some holes in this box for a bearing. So I also have my bearing test plate model set up, so I'm recalling that I had done some printing tests and found that printing this cylinder to 9.75 millimeters in diameter fits nicely inside the 10 millimeter bearing, which is nominally 10. We have this 1/8 inch square steel shaft to keep everything from spinning on itself, and that prints well at 3.67. And then the outer diameter of the bearing prints well at 15.5 millimeters. So I know that I want, the pinion is going to be on the generator, which I don't know if it's still a pinion if that's the case, but we know we're going to want a cylindrical hole of some kind here on the gear. So let's see, with that ruler still active, I should be able, and the cylinder selected, we know that we want that to be 15.5 millimeters in diameter. So I'm going to change these 20, which is the default, to 15.5. And then if I center this at 0, we're moving in the right direction. And we might recall that this distance, the center distance for this gear, is negative 45 millimeters. Okay, we could also use alignment to bring it into line with the gear, but since I have the ruler placed, I'm just going to keep on using that. It looks like I may also want to hit the D button, somehow drop this hole down onto the work plane. Okay, and it looks like it is there. So, simple as that seems, given that the base is 7 millimeters thick and my bearing is not that thick, I have to consider whether I want this hole to go all the way through or if I want some kind of stop for the bearing. Okay, before I go too much further, let's point out that we can click our two gears here and we can hide using either Control H as a shortcut or hitting this little light bulb. We can hide those gears and we can bring those back at any time. So this way we'll be able to better see what's going on just with this hole we're trying to place. So I had measured the thickness of my bearing, and it is 4 millimeters thick, and the plate is 7. So if I were to bring this hole for the outside diameter of the bearing up, if I were to bring that up from 10 millimeters now, if I bring that up to 14, that's going to bring it off of the build plate, and it's going to leave a 4 millimeter. I think I want to bring that up to 13 millimeters. Okay, because I want the hole to protrude 4 millimeters into the plate. Okay, now I could group these and make that hole, but I want to do one final thing, which is add another hole that the inside of that gear can get into. And I know I want this hole to be 12 millimeters. It's going to be smaller. than this hole, and I want that to go all the way through the plate. I do want a hole all the way through the plate, just don't necessarily want it to be the size of the bearing, or the bearing could just slip all the way through. I want something to catch the outer race. So I'm going to 0 this distance. My ruler is still active, and we know that we want this distance to be negative 45 to center it up with that original cylinder. So I think that that is my cylinder, so something very awkward happened there, obviously. I think that I accidentally zeroed the diameter instead of the distance. So we're 12 by 12, and I want to 0 this distance on the X and negative 45 on the Y, and I want that smaller hole to go all the way through. Now I'm ready to select all of these objects. Well, while I have this selected, I might as well 0 up and center that piece anyways. I'll select everything by getting it inside the circle, or I could Control A. I'm going to Control G, or I could use my group function up here. And now, if that was all very confusing, I think now you can see what we were aiming at here. So we have the ability for a shaft to go all the way through, but we have this little lip that the outer race of the bearing will sit on so that the bearing doesn't slip all the way through the plate. And I'm going to actually undo with Control-Shift-G, or ungroup, because I notice as I look at this that I want to come in and increase the number of sides on these and bring them all the way up to the maximum number of sides. It's going to be somewhat challenging, I think, to catch that smaller cylinder. There it is. Rather than 20 sides, I'm going to increase that to 64 so that they are just more round, less polygonal and more round. Okay, Control A, Control G for group, and now we have a smoother round hole for one bearing.